My name is Charles Desala. I am a research administrator at Tokyo Tech, and it's my honor to welcome you all to the 2024 Tokyo Tech Research Showcase, Various Modalities in AI for Industry. Before we start, I have a few notices. First, regarding the Q&A. So there will be a Q&A following each presentation. And for those of you joining via Zoom, please use the Q&A function in the Zoom toolbar. We'll try to get to as many questions as possible. Also, for today's event, it will be recorded, and the recording will be posted on the NSTDA and Tokyo Tech websites. So thank you in advance for your cooperation. Also, we have a questionnaire. So there's one in your packet, and for those of you joining via Zoom, we will send you the link via email. So please do let us know what you think of this event. It will help us to make improvements in the future. So Tokyo Tech Research Showcase is organized by Tokyo Tech Annex Bangkok, co-sponsored by Tokyo Tech and NSTDA, and supported by Jetro Bangkok and Taikuramai Kogyokai. Thank you all for your support. If you have inquiries, please contact us with the information shown at the bottom of this slide. So now we'll move on to our program, and we will begin with our opening remarks. Our first speaker will be Professor Nobuhiro Hayashi. He is the Vice President for International Affairs at Tokyo Tech. Please join me in welcoming Professor Hayashi.
Okay, so dear participants of the Tokyo Tech Research Showcase 2024. So I'm Nobuhiro Hayashi, the Vice President for International Affairs of Tokyo Institute of Technologies. Thank you for taking time out of your busy schedule to join us today. I'd also like to thank those of you who are participating online. And I would also like to express my deepest gratitude to all those involved, including all our staffs, or all NSTDA, related staffs. Thank you very much again. So since 2007, Tokyo Tech has been operating TICE Tokyo Tech, a cooperative graduate school in collaboration with related institutions in Thailand, including NSTDA or the other universities. We have contributed to human resource development in Thailand and created a wide and deep network. Tokyo Tech Annex Bangkok was established in 2018, and in addition to educational activities such as TICE Tokyo Tech, we have been focusing on information activities and creating collaborative research opportunities. Tokyo Tech Research Showcase is an event that was first launched only recently, and it has continued online, even during the period of the COVID-19 pandemic when we could not travel. As a result, several collaborations have been already achieved. The theme of this sixth event is various modalities in AI for industry. Generative AI is rapidly changing our lives, and how to effectively utilize AI has become an urgent issue for society, as you know. Especially in an aging society, including Japan, as the highest one with a declining birth rate, the effective use of AI is extremely important to sustain industry and is a theme that should be addressed by industry and academia. I want to include the other stakeholders, including citizens and government, in the near future, and we have already started such activities not only inside Japan but also overseas. In this event, Tokyo Tech and NSTDA will present the latest research result and exchange opinions with the business community and academia in attendance. there will be enough time for networking after this presentation, so we hope that you will deepen your exchange with each other. So one more thing I must mention to you is the integrations of Tokyo Tech and Tokyo Medical and Dental University that will take place in this October. These two universities, both with long histories, will abandon their names and be reborn as Institute of Science Tokyo. Please remember the new name, Institute of Science Tokyo. Since we have made the decision to come together with such determinations, we must make great progress towards the futures. Our primary goal is to develop a convergent science by integrating the technological potential of both universities. We look forward to this big change. This event of today will be the last of its kind of a Tokyo Tech, but we will surely continue holding it as Institute of Science Tokyo next year as well. We look forward to your continued support. Finally, I'd like to thank NSTDA for its cooperation as a co-sponsor. Thank you again. And the Tokyo Tech Alumni Association Thailand for its support, and JETRO Bangkok for its new support this year. I believe this will lead to the fruitful and attractive development of both countries for long-lived societies where everyone can truly feel the happiness of living longer. Thank you very much.
Thank you, Hayashi Sensei. Our next opening remarks will be by Dr. Patchralita. She is the Vice President for Science and Technology, Human Resources Development at NSTDA. I understand that she's also an alumnus of Tokyo Medical and Dental University. Yeah, so I look forward to becoming fellow alumni with you. Please welcome Dr. Patchralita.
Professor Nobuhiro Hayashi, all participants online and on-site at Lama Garden Hotel. Thank you for joining the 2024 Tokyo Tech and NSTDA Research Showcase. NSTDA and Tokyo Tech established the Human Resources Development Program, the international graduate program called Thailand Advanced Institute of Science and Technology, or Thai Tokyo Tech program, to implement the joint graduate program with Thai University, namely King Mongkut University of Technology, Thonburi, King Mongkut Institute of Technology, Lat Krabang, Sirinthorn International Institute of Technology, เกษตรศาสตร์ and Mahidol University. This year, the National Research Council of Thailand has joined our program as a very strong support partner. Tokyo Tech and NSTDA expect that research and innovation are very important for the lifting the capability of industry. Therefore, Tokyo Tech and NECTEC aim to be the bridge between NSTDA as the National Research Center in Thailand and Tokyo Tech as the academic and research institute in Japan to contribute to industry in Thailand, Japan, and neighboring countries. The Tokyo Tech and NSTDA Research Showcase is one of the activities with Tokyo Tech and NSTDA used to introduce cutting-edge technology to the industry. The topic of today, various modalities in AI for industry, will be advantage across many sectors. Generative AI is one type of AI which use artificial intelligence algorithms such as ChatGPT to create new content, include audio, code, image, text, simulation, and video. Recent breakthroughs in the field have the potential to drastically change the way we approach content creation. Generative AI is crucial for autonomously creative, diverse, and realistic content, driving innovation in creative field, improving machine learning or data augmentation, aiding simulation and training, enhancing anomaly detection, contributing to drug discovery, personalization, artificial creativity, and refining human-computer interaction. Its versatility addresses various challenges, making it a key technology for fostering innovation and efficiency across industry. Today, we will have the researcher from Tokyo Tech and NSTDA to share their generative AI-related research with us. I truly hope that all of you will gain insightful knowledge and discover new opportunities from today's showcase to be applied to your organization. Finally, I would like to express our gratitude to our counterparts, Tokyo Tech, for today's showcase, Nada, and I hope that you all feel comfortable to ask questions and share your insight as we proceed. Thank you.
Thank you, Vice President Patchralita. So now we'll proceed to our first speaker. He is Takahiro Shinozaki, an associate professor at the School of Engineering at Tokyo Tech. He will speak about spoken language acquisition by autonomous agents in intrinsic motivation. Please join me in welcoming Professor Shinozaki.
Hello. Hello. So I'd like to talk about this title. I have been working on speech recognition, but the conversion problem of speech signal to character sequence has been greatly improved. So nowadays, I am more interested in the understanding and the learning aspect of spoken language. So can you see the next slide? Okay. So, oops. So this is human speech language acquisition. And the way of learning spoken language we learn is radically different from the current spoken speech recognition system. So in the individual level, we can learn deeply meaning-grounded language without relying on labeled data, including hard-to-label elements such as intonation and facial expressions. And our language ability is linked to our cognitive ability. So the learning and the understanding ability of language is very important, not just to converting problem of signal to character sequence, but it is essential for human intelligence. And at the social level, our language has an ability to evolve on its own. So nowadays, large language model is very, very powerful, but it basically imitates our data on the internet. So it's basically just an imitation. But our language has the ability to evolve by itself so that it is open to features. So that is a limitation of current learning method. So in short, agent learns spoken language based on data, prepared data, where the label given by developer or engineers. So that means it cannot directly learn from interaction with us. That means the mapping from the observation by the agent, like vision and hearing, and to its action is to the level of a given level. So it can only work within this framework. So if we can remove this boundary and make the agent can directly learn from our society, then that is extremely extends the ability, communication ability of the agent, and this is our motivation. The early view of language acquisition is given by Skinner. So he explained the language learning as the mechanism of operant conditioning. And so this is the kind of initial idea of reinforcement learning. And the Chomsky against it, his Skinner, he said that careful shaping of children's vocalization is not likely. It is kind of reasonable because speech utterance is very, very complex, and it is actually difficult to learn it from just simple reinforcement learning due to the efficiency problem. And instead Chomsky said there should be a universal grammar. And this again has many discussions. So the language acquisition is a kind of involves very wide area. So in this slide, Skinner is here, and then Chomsky here. And Tomasello emphasizes the importance of interaction and imitation. And in the spoken language processing area, the first very pioneering work is given by Gorin at Bell Lab. His developed system was a type of co-routing system, and the system could run new vocabulary from the interaction with the user. And However, the research on spoken language acquisition is kind of very minor until recently due to the limitation of the available tools and computer power. But nowadays, we have many powerful tools, so I think we have, kind of ready to attack this very challenging problem. So in summary, the limitation of existing research is that we can classify existing research in two groups. One is, sorry. So one is based on reinforcement learning, and the other type is based on imitation and the co-occurrence modeling. And the limitation of existing reinforcement learning-based approaches is that they are based on maximizing rewards from users and specific scenarios, and the lacks generality aspect. On the other hand, imitation and co-occurrence modeling-based studies lacks the ability to learn language based on try and error. So our goal is we want to consider a model that can achieve language acquisition from a more fundamental perspective. So this is our proposed formulation of language acquisition. So to consider the deep understanding of language, we began with formulating the problem. So as in this figure, agent should have, to the agent to be autonomous, it should have an internal desire, and it have some internal states. Internal states can be everything like preferences or knowledge or battery level and so on. And we assume that as a setup, we assume that agents have internal states which are invisible to the external world unless it expressly express. And agent act based on the fulfillment of internal desires. And initially, agents do not possess specific language knowledge. And it do not equip any vocabulary or grammar of specific language like Japanese or English or Thai language or anything. And agents can influence the external world only by speaking. So, it's okay to the agent communicate to the world by other means, but because our interest is in language acquisition, so in this setup, I have limited to the interaction between agent and the world by spoken utterance. With this setting, and with proper learning mechanism, we can expect that the agent can acquire spoken language based on the interaction with the world without assuming any prior knowledge. And to realize language acquisition based on this formulation, we have proposed basic structure of the language acquisition agent. So it is based on end-to-end neural network, and it has external observations like vision and hearing, like eyes and camera. And it has the internal state, which is hidden from the outside. And it has the desires or reward evaluator. And based on this input, it generates its action. Action means, in this case, the spoken utterance. So by giving enough iterations of conversation based on reinforcement learning, we can expect that the agent behaves so that it maximizes satisfaction level, internal satisfaction level, and by speaking. So speaking is a means for the agent to maximize its internal desire. And as a process, we can expect that the agent runs spoken language. However, there is a big issue to make this work. So the point is that attempting to use continuous speech signal directly as action in reinforcement learning results in an exponentially large action space. Because the speech signal is a sequence of numeric value, and the complexity is exponential to its length. The probability that randomly generated actions, utterances, will be effective is extremely low, making learning efficiency impossible. At the beginning of the learning, agent doesn't have any prior knowledge, so it just randomly try generating some sound signal. But because of the complexity of sound signal, the probability of generating meaningful utterance is mostly zero. That means the agent cannot obtain successful experience. Without successful experience, the learning cannot proceed. So there is a need to reduce the entropy of generating meaningful spoken utterance given the external and internal states in action generation, utterance generation. So this problem is actually, very quite related to the Skinner's and Chomsky's deviation. So for this problem, we propose the initial version of our proposed method is this one. So our basic idea is to combine unsupervised learning to improve the efficiency of the reinforcement learning so that the entropy of generating the meaningful utterance is reduced. So in this method, we first perform unsupervised word learning, like using ES-K-means method, and automatically finds repeating pattern in the continuous utterance, and make the sound word vocabulary in the, by observing the sound utterances. And once the agent makes the sound dictionary in an unsupervised manner, it uses the dictionary as the discrete action space for the reinforcement learning. So by doing this, the entropy of generating utterance is drastically decreased. So originally, it's the log of speech signal space, but now by using the dictionary, it is reduced to the dictionary size. Because unsupervised dictionary is quite noisy, but and because we put the priority to the recall rather than precision, the dictionary size is much larger than the necessary vocabulary, but still the entropy is drastically decreased from very large continuous space to the limited number of vocabulary. So this is the basic idea. And to try this idea, we have performed an experiment. The running task is like this. Here, we assume an agent or robot is randomly positioned in a 3D space. And we implant the agent, integrate the agent, the intrinsic motivation that it wants to go to the origin in the 3D space. It's like, intrinsic motivation means like pigeon has a motivation to go back to its own home. So like that, we have implemented the motivation, the agent to want to go to the origin point. And this is the only internal motivation that we explicitly implemented. Other than that, we do not implement any language information with the agent. And then the agent observes, analyzes the spoken utterance, unlabeled spoken utterance, like this.
Left.
Backward. Forward.
Marvin.
Backward. Backward. Up. Right. Forward. Up.
So in this setting, by pronouncing a spoken command of direction, the agent can do one step to that direction. It is like the agent is on a skateboard that recognizes speech command, and then by speaking the direction command, the agent can move to one step to that direction. And yes, with this setting, so this is the experimental result. At the very beginning, agent has no idea of what speech commands are available and what language it is. It just observes, spoken utterance. And then after obtaining the word dictionary, it tries to pronounce it, by try and error. At the first epoch of the dialogue trial, this is the movement of the agent. The red point is the agent in the 3D space. Because in the early stage of learning, it has no idea of what command to say, so the movement is just random. And these are the example of the robot utterances.
Left.
Back.
Oh.
Because the vocabulary is run in an unsupervised manner, some words is kind of meaningful direction command, but many of them are just a broken word segment. And after 5 episodes of running, now the agent learns what to pronounce, what command to pronounce at what situation. And now it can move efficiently like this. So just very smoothly go to the origin point. And these are the utterances of the agent.
Up. Up.
Maybe this one.
Right.
So now they are all meaningful spoken commands. And so it worked, but apparently there are many limitations with this simple approach. So first one is a greater amount of trial and error is required in proportion to the vocabulary size, because the vocabulary, the dictionary size is much larger than the real effective vocabulary size because of the noisy unsupervised word learning. The vocabulary size is very large, and the search space is linear to the vocabulary size. So with the increase of vocabulary, the learning efficiency is decreased. And because it is based on the dictionary sound playing, it can only produce word-based utterances. And due to the utterance being recorded to playback, it is difficult to express intonation and emotions. So our next target to extend this idea. We firstly extend it to address the first problem. So the idea is that if we observe how we learn spoken language in our childhood, so it's often the parents show some image to the child and say, this is apple or red apple or something. Then the children learns the association between spoken utterance and the image object gradually. And that means by utilizing this, situation, we can reduce the entropy of utterance generation. That means the utterance generation, we can expect the utterance generation is conditioned by the situations, scenes. And by running the association between image object and speech signal, we can, reduce the entropy of the word generation given the scene information. And by integrating this mechanism, we succeed to improve the learning efficiency. And the next extension was to address the second and the third problems. Mainly second problems. It could only use word-based utterance because it is based on dictionary-based action space. So the idea was to use the language model and the speech synthesizer. The challenges are that, in this scenario, we have to learn these components in an unsupervised manner. So to do that, we have, today I skip the very detail, but the basic idea is we have integrated several types of unsupervised learning to pre-train this language model, which replaces the word dictionary. And we also trained the speech synthesizer in an unsupervised manner. And also, we prepared embedding space of kind of some concepts or utterances of fixed lengths. And then we use this one as the action space of the agent utterance. And then we succeeded to make our agent run some phrases instead of utterances within, limited given small amount of dialogue trials. So yeah, so the details is in our paper. So our target is to make the first motivation is to run the language based on reinforcement learning. But because it cannot work by itself, we seek for the method to make it more efficient and introduced several components. And as a result, now our agent have some structures. And the obtained structure has kind of similarity with our brain structure. So it is interesting to consider the correspondence. So we have a unsupervised pre-trained image frontend, which corresponds to official lobe. And also we have a sound input, which corresponds to the sensory speech area in temporal lobe. And also we have parietal lobe, which integrates the several modalities, which correspond to this part of the agent. And the action generation and the utterance speech waveform generation from this embedding space correspond to the frontal lobe, and like this part correspond to the Broca's area. So now kind of we are more interested in the realizing kind of minds, tackling the mind problem. And yes. So maybe we can consider applying psychological method to analyze the spoken agent so that investigate where the mind exists. What we are observing is output of auditory cortex and higher visual cortex. And our mind is believed to existing around here. I mean, there are many discussions also, but maybe we can find the correspondence between automatic agents that have language learning ability. So in summary, formulation of speech-language acquisition form from the perspective of reinforcement learning was conducted, and the speech-language acquisition agent to realize it was proposed. Observational learning, which involves unsupervised word learning, audio-visual grounding, and language model learning, has been shown to be effective in improving the efficiency of reinforcement learning. The future work includes scaling up the language model and generalizing dialogue tasks, transitioning from simulation experiments to real-world evaluations, and implementing a physical speech synthesis system using the embodiment of vocal organs, and establishing a method for designing reward evaluation systems. Maybe we can think about reward programming instead of directly programming the agent behavior, and the expansion into the field of cognitive science. And we have software release at this website. Okay, thank you very much.
We're a little bit behind time, but I would like to take at least one question, if we have one among the audience or on Zoom. Does anyone have one question for Shinozaki Sensei? I have one question for me, if you'll take it. So our theme today is AI for industry applications. So your method here is, I think, trying to model the ways that humans learn language. How would that apply to, for example, an industry setting?
So the program of language learning and eventually the mind is very important in to understanding the human intelligence. And in that sense, it should be very important in industry applications. But if we think about short-term goal, the gap is very large compared to the current technical level. So if you seek to the short-term goal, maybe there is no big impact. But in the long-term vision, it has very, very strong, fundamental question to human intelligence and to realize agent that can work, behave like humans. So in the long-term range, it is essential problem.
Very exciting. Thank you very much.
Thank you very much.
Once more, let's thank Dr. Shinozaki. So now we'll move on to our next speaker. He's Manabu Okumura, a professor at the Institute of Innovative Research at Tokyo Tech. His talk today is on language processing and its applications in the age of pre-trained models. Please welcome Professor Okumura.
Thank you for the introduction, Chairperson. So, good afternoon, everyone. So, as you see, today's my talk is on language processing and its application in the age of pre-trained model. So, as you might know, our field of natural language processing has been overwhelmed by the rapid development and prevalence of pre-trained language models. So maybe one of the most famous one is, as you know, ChatGPT. One of the so-called large language models, LLMs. So today, I'd like to talk about what issues we need to tackle in these days by taking into account the problems for the pre-trained language models. And then I'd like to also give a presentation on what industrial applications are possible in our field by taking into account our own case studies. Okay, so let me start from the old story of our field or our technology of language processing. So as you see in this slide, we have started our technologies from, the heuristic or rule-based technologies. So we can easily customize or construct our own systems manually. And when we could find traditional machine learning frameworks that can be applicable to our own technologies of language processing, we have utilized them, and we can have much improved performance for most of the natural language processing tasks. And among them, as you know, neural network frameworks emerged as a winner, and they almost dominate our field of natural language processing. And finally, in these 5 years, as you know, we now have another breakthrough of pre-trained language models, and the performance has been dramatically improved in most tasks in our language processing. However, as you might know, we now have a serious problems in the age of pre-trained language models. So first of all, as in the second itemization. So end-to-end training for neural networks and pre-training for the pre-trained language model might cause the difficulty of controlling models. So almost everything has been done by the trained models, and we cannot control them at all, almost at all. And another famous problems is the computation, the high computational cost for pre-training or training the pre-trained language models. So, and we need to mention more problems in utilizing neural network frameworks in language processing. And so here again, we now have a quite famous problem for them. And the first one is the famous one, so-called hallucination problem, that the system tend to generate unfaithful document, even when they are given some images or documents as an input. Another is, as I will illustrate from now, is a bias problem in text generation. So let me utilize quite typical two examples for the bias in text generation. So given the prompt, the nurse believes that the system tries to output the next word. And it was found that the probability of generating she is much higher than he. However, as you see in the next, when we try to replace nurse with CEO as the prompting word, the situation is completely changed. So the probability of he is much higher than she. So it can be the well-known gender bias in text generation. And another illustration of the bias is given for some specific attribute in the generated text. So when we try to ask the large language models to generate some document related to the word labeler. So given the prompt, including the word labeler, the generated text tend to exhibit a neutral sentiment. However, when we try to enter the word CEO for the prompt, the generated text tends to possess much higher positive sentiment. That indicates the CEO might be quite related to some positive sentiment. So in sum, we can find that we need to tackle at least the following four quite important problems when we try to deal with and to utilize the pre-trained language models, especially the large language models such as ChatGPT. So here, I'd like to briefly mention our own work to deal with such problems from now on. However, please note that it is quite difficult to introduce the most recent our work because it they are not still published yet. So I apologize. Our work on large language model will not be mentioned at all in today's talk. So let me skip a couple of slides and let me start from the first topic of how to control the pre-trained models. So here, the setting or the task to be targeted at is abstractive document summarization. So when we try to input a document, the system should try to output an abstractive summary. And in this setting, we can find that the system feels some difficulty to generate a summary when the summary length is not given to the system. And the reason might be quite simple. It can be quite it can be also problematic even for human created summaries. So when we do not have any information of the summary length, we tend to think of the difficulty of estimating the volume of the important content in the document. So we should try to incorporate some good clue information of the summary length to the system when we try to improve the performance of the system. So as you see in this figure, we try to incorporate another task to be solved by the encoder of the model, that is to predict the summary length for the given document. So by utilizing this predicted summary length information in the summary generator, we believe the performance might be improved. And so this would be the idea of how we can control the summary generator that was pre-trained by some large training corpus. So let me move to the second topic of improving the faithfulness of the generated document. And the target is rather different from the previous one. So to generate weather forecast comments from such a numerical forecast map. So truly, this is our joint work with weather forecast company in Japan. And as you might know, in Japan and presumably in most countries, weather forecast comment can be manually created by meteorological experts from such a sequence of weather forecast maps that is the simulation results from the huge supercomputer. So why not constructing an automatic weather forecast generation system? Because as you know, given a specific time and a specific location, meteorological experts usually try to prepare numerous weather forecast comments. And it can be quite time-consuming and labor-intensive. And so the usual model would be like this one. So first of all, a sequence of numerical forecast maps will be encoded in the model. And after that, a weather forecast comment will be generated in the decoder. However, in this ordinary modeling, sometimes the system tends to generate unfaithful document that might contain a lie in the generated document. Therefore, we need to improve the faithfulness of the generated document, and how should we do? So in this case, the idea is quite simple. So the most crucial information in the weather forecast comment is the predicted or estimated weather itself. So we first try to incorporate another task of predicting the weather forecast label to the encoder part. And by incorporating this predicted weather forecast label in the phase of generating weather forecast comment, we think the generated weather forecast might be improved in that, in terms of the faithfulness. So this would be the idea for improving the faithfulness in generated documents. So let me move to the third topic of debiasing the model. And here, please note that we try to debias the model with smaller training cost. So it would be the crucial point for debiasing. So as I have mentioned, so in the pre-training and fine-tuning, we think they might be quite high cost. Therefore, even in the phase of debiasing, if we need much higher training cost, it would be meaningless. Therefore, we try to debias the pre-trained model with smaller training cost. And here, again, the work is for the fine-tuning setting rather than the pre-training setting. And I'm sorry that we cannot talk about our work for the pre-training setting because of the unavailability of our current work because of the unpublishment. So let me briefly talk about the detail of our idea. And so, as I have mentioned, we try to debias the training data for fine-tuning in this setting. And since we try to utilize the GPT-2 kind of language model for the base model, so the fine-tuning would be done by PFT, parameter efficient fine-tuning method. So more specifically, we have utilized prefix tuning in our fine-tuning. So we usually prepare a specific prefix for the fine-tuning. And if we utilize this specific prefix alone, as I have mentioned, due to the bias in the training data set, the result might be biased. So how should we debias the model? And the idea is quite simple. So we try to incorporate another prefix that tend to be trained with the whole data set. That might include the bias of the training data. And as you see, we try to apply the logis subtraction in the model to debias the general prefix in the model. So the debias can be done just by the logis subtraction. So we believe this might be done by quite small training cost. And lastly, in the fourth topic, we have done a couple of work. However, due to the time limit, so I have just mentioned one work that we believe it is interesting. So let me illustrate our second work of applying dataset distillation in natural language processing. So truly, as I will mention later, dataset distillation is quite popular in computer vision fields. However, truly, in our field of language processing, the technology might not be quite popular. And it is because our target data text is discrete in the characteristics. So truly, our work to apply dataset distillation in natural language processing can be considered to be almost the first one to utilize the technology in fine-tuning the BERT pre-trained language model. And the idea of the dataset distillation is try to yield comparable performance to the training with the whole or full dataset, only with a couple of training instances in fine-tuning. So we can drastically reduce the training cost by applying dataset distillation. So let me briefly mention our work on fine-tuning BERT by taking into account that dataset distillation. So as I have mentioned, this dataset distillation tries to reduce the whole training dataset into a quite small set of synthetic data. And due to the time limit, so I will skip most of the technical details, and let me mention the interesting results from our work. And as I have mentioned, in this experiment, we have just utilized just a single training instance with just one training step. As you see, almost comparable performance can be obtained for the text classification task. So we can say that just one synthetic training instance is enough in our work for yielding the comparable results with training with the whole data set. And so, unfortunately, I'm running out of the time, so let me move to the last topic of how we can apply our technology in industrial applications. And I'd like to mention just one. So, as I have mentioned, weather forecast generation can be a joint work with weather forecast report company. And so let me mention another industrial application, that is add text generation. And as you see, add text generation can be considered to be a task of query-based summarization. So as you see in the left bottom, the input is a set of keywords and a content of a web page. And we try to generate and add text for the web page. And usually, we try to compare generated text, generated alt text with a reference to train the model. However, in our work, so we try to incorporate reinforcement learning. So, more specifically, reinforcement learning with human feedback. So, as you might know, this technology might become quite famous in constructing ChatGPT or in training the ChatGPT. So, however, in our work, we have utilized the same technology in the past. And as you see, we first try to prepare ad quality estimator that was trained by taking into account the annotation from the human feedbacks. And so we now have the tool for estimating ad quality, and this estimator can be scoring the generated ad document. And this score might be utilized as the reward in reinforcement learning. Therefore, the model can be trained to yield better summary with higher reward, that is, higher quality as the ad document. So in this process, we can improve the ad document by taking into account this estimator of ad quality. Therefore, we can generate much diverse ad document by taking into account this estimation of the ad quality. So sorry, so the time's up. So let me finish my talk. And truly, another application might be medical report generation, and it can be the explanation of the medical diagnosis. However, due to the time limit, so I need to finish my talk. So thank you for your attention, and sorry for my rush talk with various topics. Thank you.
Sensei. I'd like to take questions from the floor or from Zoom if there are any. you have a question, feel free to raise your hand and we'll bring the microphone to you. Okay, this one over there.
Hello, thank you for your talk. It's really insightful. And I actually want to hear more about the use of generative AI to generate a medical report. Yeah. But so in the first section, you talk about some bias that could be happen from the using the generative AI or some hallucination. So I wonder if to use the large language model to generate the medical report, are there any kind of obvious biases that could happen? Thank you.
Yeah, thank you for your good question. So truly, hallucination has also happened even in the medical report generation task. And as you know, in this setting, so it is quite crucial and fatal when we found some lies or counterfactual point in the generated document because of the sensitivity of the medical report. So maybe the crucial and the important point in improving the medical report generation is, as you suggested, try to improve the faithfulness. And truly, we now have many trials or proposals to do so. And so thank you. So due to the time limit, I could not explain the detail of this work. But so in this work, we try to we try to improve the alignment between textual and visual features to improve the performance or the faithfulness of the generated document. So one difficult problem in this task is to find the relationship between visual and textual features. Therefore, in the first step or in the first work for medical report generation, we try to focus on that point to improve the alignment between these two features. And truly, the performance can be much improved in our work. However, truly, we have not evaluated the faithfulness in this work because it is quite difficult to evaluate the faithfulness of the generated document. So maybe the better way is to manually evaluate the generated document. However, since it is quite time-consuming, so we have not tried it yet. So, as you suggested, it is a good point for the future work, I think.
Thank you, Okumura-sensei. I'm sorry, we have to move on to the next speaker. Eh? I believe there are more questions and also online as well, but please wait till afterwards for the further questions. Thank you again, Okumura-sensei. So our next speaker is Dr. Prachya. He is a researcher at the Language and Semantic Technology Research Team, Artificial Intelligence Research Group at NECTEC. His talk will be Open Thai GTB, Large Language Models for Thai. Please welcome Dr. Prachya.
Okie dokie. First of all, It's my pleasure to give a talk here. As I'm a fast talker, if I start mumbling, just raise your hand and say, hey, stop mumbling, okay? As always, my name is Prachya from NECTEC, and I'm working on large language models. Actually, this project is a collaboration between 3 bodies, which I'll be talking about very, very soon. My name is Arm. You can call me Arm, but my full name is Prachya. By the way, my PhD topic was about grammar induction, where we extract the grammar automatically from raw text, and I also combine Chomsky universal grammar into the machine learning model so that it boosts the accuracy quite a bit. That was back in the day, about more than 10 years ago, so I forget all about it already. So anyway, I'm not talking about it. I'll be talking about large language model, which is one of the collaborative project between NECTEC and other bodies. Without further ado, this is OpenTyGPT. OpenTyGPT is a collaboration between NECTEC, AIAT, or the Artificial Intelligence Association of Thailand, and also AIET, or Artificial Intelligence Entrepreneur Association of Thailand. And not only that, Thais has also played an important part in this project, because 2 of our students, between Professor Okumura's and my students, work closely with this project. Therefore, it's my pleasure to be here. Anyway, this project is quite important because it's actually one of the first language models for Thai. As we all know, generative AI has played an important part right now. ChatGPT, Microsoft Copilot, and Google Bard show performance boosting quite a bit from what it has been before the large language model. However, all of these models are actually based on machine translation. If you speak Thai or Japanese into the model, it translates everything into English before working. That is a problem because there is always loss in translation. We always need monolingual language model. And that is the main motivation for this project. OpenTyGPT is oriented by Thai language. So we try to develop our own language model, large language model for Thai. And anyway, we cannot start from scratch. No, we cannot do that. We need something to get on top of. Okay, so far so good. Before we get to the project, let me explain a little bit more about the large language model. With a 1990s retrospection, the language model is actually a statistical model for predicting the next word. So it's like guessing the next word. What would be the next word given the context? And if you take a look at the equation up there, it's actually guessing. We predict the next word based on the context. So far, so good. That was back in the day, in 1990s. But now, as a large language model, we need a huge amount of data to train it and get it reliable. We need at least 1 billion tokens or 1 billion words to make the large language model reliable enough because it needs to learn word collocation and phrase structure from the data. And to give some example, some of you may have already known this song. So we need to guess the next word from the context. So this is the song from the Carpenters, When I Was Young. The next one would be, I listen to the radio waiting for my favorite song. Yeah, that is the song. If you know the words, that is Yesterday Once More. It's a very popular song in 1970s. Oh yes. If you can sing along, I think I can guess your age, okay? Anyway, to make the guessing reliable, we need the model. And the model is transformer. The transformer model is actually sequence-to-sequence generation model. It learns from the data automatically 3 things. First, it learned word collocations. What are the idioms in the data? It learns on both sides. If it's a translation, it learns, for example, the source language and the target language. That is the first part. The second part is the phrase structure. How would you rearrange words to form a sentence? It learns them automatically on both sides too. And the last one is about translation. It learns the alignment or the mapping of translation. With 3 kinds of information extracted automatically from the data, you can have a reliable transformer. And the transformer is actually the last abbreviation, the last letter in the abbreviation of GPT, Generative Pre-trained Transformer. So if you can train a reliable transformer, then you can have a GPT. So far, so good. That is how it works. That sounds simple until you take a look at the data. It's another story. To build a reliable LLM or a large language model, you need a lot of data. Huge repository of data must be given. And that is how we start the project. We start the project from compiling data from multiple sources, and one of your students are here, Professor Okumura, your student are over there. And so he's one of the key men for the project. These are the data sets. It consists of about 2 trillion words of Thai data. But believe it or not, the majority of the data is just garbage. You cannot use them at all. You need to clean the majority of them out, leaving only about 40 billion words. That is clean enough. After cleansing, after anonymization, after removing the HTML tags and stuff, so you've got only 40 billion words. Luckily, we've got multiple data providers like Puntip.com, a very popular web board since 1990s. Oh yeah, I grew up with that. Okay, so they donated a lot of data for us to train a reliable large language model. So at the moment, we've got about 60 billion tokens for the large language model. The OpenThai GPT started from that point. But it's not only that. That's only the first part. To train the model, you need a huge computation power. So we talked to Thai SC, Thai Supercomputer Center, and we started a project with them. We trained the model, not only the Llama or the GPT. We trained many more models like Electra, BART, DiBerta, and also we are looking forward to include the multimodality into the model as well. I'll talk about it later. I'll try to go slow. As you can see, I'm trying to slow down my pace, okay? Anyway, we have one motivation. We want to include Thai into one of the pivotal languages. It means the Thai large language model must be reliable enough to work on the real data. And the OpenThai GPT has already been released several months ago. And at the moment, we release 7 billion parameters and 13 billion parameters already. We are training the 70 billion parameters at the moment, and we will release that soon. Everything will be publicly available and open source. Okay, you can try it out today on this website, which is the AI for Thai platform. And also, you can take a look at our Hugging Face because it's already on there. Why not? Just try it. Okay, and the base model is based on Llama. I talked to the guy, Mike Lewis. He's my friend from Edinburgh. And he was the inventor of Llama. And I asked him, how could I pronounce that name? Is it Llama or Yama as in Spanish. He said llama. Okay, so llama, as the inventor says. Okay, and we evaluated our model on the leaderboard with respect to the natural language understanding for Thai, and we're still the leader up there. We're still the leader. But this table may change very soon as we've got more players to come in. At the moment, the OpenThai GPT can work, has some capabilities of working on question answering, trip planning, just like the ChatGPT does. But everything is in Thai. It understands English, Chinese, Japanese, and all of that. Every language that Llama version 2 understands it, but it will answer to your question in Thai. Sorry for that. Okay, anyway, that is the first version. And we don't stop there. The Llama version 2 or OpenThai GPT is a large language model. It's okay. People see it as a toy. How could we apply that to the industry? One way to do it is to incorporate the search engine into it. We call it Retrieval Augmented Generation or RAG. When we incorporate large language model into it, the RAG works as Google on steroid. It means it's a very intelligent Google. If you ask a question which is not in the knowledge base, pointer, okay, over there, like what is the thing on top of the pyramid? If the large language model doesn't know that, it will ask Google or information retrieval system, get relevant documents, and incorporate the answer into the question and compose the answer. RAG is very simple in ideation, but it's quite challenging in terms of research. How would you make sense of the answer? Things like that. So that would be the next step for the RAG. The ecosystem for the large language model, just like OpenThai GPT, is much, much wider than you think. Let's take a look at the world arena. Here, for multilingual language model, just like English, for example, majority is English. So we've got multiple players here, like many, many players over there. And for Chinese, we've got some more. And they are all very large model. Let's take a look at that. When we say 7 billion parameters, it means 7 billion neurons in the brain. So the more neurons, the more capable the large language model can do, okay? That is the thing. And right here, for Thai, OpenThai GPT is over there. We've got 7 billions and 13 billions. And we've got two more players like VisTech, our partners, and also SCB 10X, which is a commercial bank. They also developed their own large language model. And at the moment, we are still on par. That is very interesting. But not only that, more players comes in too. Now we've got Southeast Asian large language model. It's multiple language. It's just like multilingual. Like Alibaba, they released CLLM in December, and also Sea Lion from AI Singapore. They also released everything before Christmas. So now we're in the position of competition. Here, that is the arena. And for Thailand, the ecosystem will be based on two parts: the HPC, high performance computing resource, and also the industry over there. Some of these are the applications for the large language model. You can use it in business or manufacturing. For example, if you have a question about some machines, you can ask the large language model how to solve the problems, things like that. It can be used in many applications. Think about it. Large language model is very beneficial. Am I running out of time? Not yet? Cool. Okay, so future direction. So instead of going worldwide only, we focus also onto the government section. That's the main part. People say, hey, don't just get involved with the government. No. We think outside the box, which is inside the box anyway. But we can think about the security critical applications for large language model. Let's say they have critical data, they don't want to release it, they don't want to get involved with ChatGPT or Microsoft Copilot. This is the place. Our large language model can deal with this kind of thing. The next one is about government services. Why not? We can do that. Chatbots, it's everywhere. Why don't we just incorporate LLM into the chatbot? Make it on steroid. The next one, we are looking forward to incorporate the chain of thoughts. Can the large language model give you reasons why they give you the answer? Can it be a reasoner or not? If it can give you a reason for the answer, then you can validate the answer. And the last one is about the multimodality. I'll talk about it later. Here, one thing is about the knowledge. When we construct a large language model, a monolingual or multilingual, the problem is about the knowledge. You may lose the knowledge along the way as you fine-tune it or as you continually pre-train it. That's the problem. And how we solve it, I cannot talk in details about what we are doing right now, but I can give you the motivation. So here, this is how we actually retain the word knowledge in our OpenType GPT language model. So here, instead of just giving the fine-tuning or downstream task dataset, no, we give it the word knowledge dataset, Wikipedia. We make it a mass language model, just like that. We put a mass on some words. And then we use teacher models. We can have multiple teacher models like GPT-4 or anything from the Hugging Face. We copy the logjits, or anything that you like it. I call it log props. We copy the log props from the choices for each mask. And we use them for fine-tuning the student model, our OpenType GPT. In that sense, we can retain the world knowledge in the OpenType GPT and make it more capable in speaking Thai. Why not? We can do that. And we are also looking forward to the multimodality where we want to incorporate the audio, the video, 3D models into the language model for physical grounding. Professor Okumura has aforementioned the physical grounding where it makes a reference between the language and the physical objects. This is how we do it. If we have image, we develop a vision transformer, transform the image into a set of vectors. If you have audio, you develop audio transformer. If you've got more modes, you develop a transformer according to it. Then you incorporate all the vectors in the sequence and train the large language model. By doing that, it starts to learn the physical grounding, the reference between the physical objects and the language. This is GPT-4. We are looking forward to do that. But the challenges are still there. Hallucination. We also take into account this problem very seriously because that impacts the reliability of the model. AI hallucination can be classified into 3 categories at the moment. Out of context generation, you ask something and it gives you something not related to the question. The second type is contradiction to previously generated context. Like it starts the answer with one thing and then it narrates to another thing which contradicts to the first thing. And the last type is misinformation. This is the most perilous one. If it generates misinformation or propagandas, it's going to be problematic. So we have to take care of all of these categories. But not only that, we also take a look at the unethical uses of generative AI as well. It's actually one of the national AI policy in Thailand, where we incorporate all kind of ethical use of AI into the policy, and it's going to be implemented soon. The bill has been passed already. So that is the overview of our OpenThai GPT project. That's everything. Thank you very much. Question time,
Yes,
right?
thank you, Dr. Prachya. If you have questions, please raise your hand and we'll bring a microphone to you.
Yes, please.
I'm sorry, but I do not know about the Thai languages. So probably each language has their own problems. So what kind of problems, especially Thai language, has compared to the other languages?
Thank you for your question. This is a very challenging one. The Thai language has several problems ahead. The first one is about word boundaries. In Thai, we don't write any space between words, just like Japanese. But in Japanese, you've got particles, you've got very simple word segmentation. But in Thai, words can be 20 characters long. So that's the first problem. The second problem is about sentence boundaries. In Thai, we don't have any full stop. That's why we never stop talking, right? So in Thai, we don't use any full stop. We use space. But the spaces will be used for multiple purposes, like comma, full stop, or declaration, or pause. So that's the second problem. The next one will be about the language itself, the syntax. In Thai, we don't have any inflection. We don't have anything like run to running to ran. No, we don't have that. That sounds simple, right? But that means we don't have any participles. We can have a pattern of noun, verb, noun, and sometimes it's really hard to detect, is this a sentence or is this a noun phrase, for example? So in Thai, the grammar is quite complex, although we don't have any inflection at all. So to learn the Thai language using the large language model, we need much more data than 60 billion tokens. We need much more than that. And that is why it's now a government level project. We need much more data from the government. We need their help. Yeah.
Thank you.
Thank you.
So thank you very much for your great presentation. So how do you think about the considerations about the manner to use OpenGPT in the scene of the educations? So yes, so the topic is so activated in Japan. So how to use, or can we permit students to use the GPT or something like that?
Yes, this is actually one of the debatable topic in the I would say the Ministry of Education has consulted us about this problem, and we have reached the point where we will allow the LLM to show up in the classroom, but not as ChatGPT. It's more like a personal assistant. Instead of answering everything that the student asks, no, we will help them solve the problem step by step. We don't just give them the answer because that's not going to let them learn. We're going to help them learn instead by, hey, did you do that already? Can you plus that number with the other numbers? And we solve that problem and then advise them step by step instead using the LLM. That would be a much wiser way of using the LLM in the classroom.
Okay.
Did I answer the question?
Yeah, I agree with you. Yes, thank you.
Thank you.
Maybe one more question, if there is.
อาจารย์สวัสดีครับ
So
Thank you very much for your very interesting update on OpenTyGPT. I finally have a chance to catch up with you, finally.
Oh, finally, yes.
Actually, I have a lot of questions, but maybe just a quick question. A quick one is, you touch a bit about the evaluation of your performance of OpenTyGPT against other so-called competitors or so other Thai LLM. What are the set of the data sets that you use to evaluate? Because I'm not aware of any standards data sets for this kind of purpose.
Give me a sec. So the data set here, the data set here are HelaSWAG and ARC, MMLU, and Truthful QA. So all of these data sets are actually for evaluating natural language understanding. Like you've got some common sense question, like how would you walk outside while
aren't
raining?
Aren't it for just English?
Oh yes, that's of course, that's a problem. Initially, we have only English common sense questions, so we translate all of them into Thai first and then evaluate. But we did that automatically using Google Translate. So everything you see right here is automated evaluation. We're still developing the real evaluation data set for Thai at the moment. It's still one of the ongoing project at NECTEC. So yes, so please wait for that.
Thank you, Kap.
Okay, thank you very much. I'll see you later.
So we'll proceed to our next speaker. He is Koichi Shinoda, a professor at the School of Computing at Tokyo Tech. Today he'll be talking about advanced object detection techniques for visual scene understanding. Please welcome Professor Shinoda.
Good afternoon. This is Koichi Shinoda from Tokyo Tech. So today I'd like to talk about the vision, computer vision kind of things. I mean, the first talk is about audio. The next two talks are about natural language processing. So this time I talk about image and video. So my title is a text-guided object detector. Oh, no, not this title. I'm sorry. これ違う。Advanced object detection techniques for visual scene understanding. Okay, so this is a brief introduction of myself. So actually, I majored physics in university, and I joined NEC Corporation after that, and I studied speech recognition, and then I joined the university and start image and video processing research. Okay, so today I'd like to, actually I'm doing many wide variety of research among multimodal, multimedia, but today I'd like to talk about object detection from image and videos. And yeah, probably nowadays you know that the deep learning has been, has been studied very well and have a high performance. And we have developed many techniques to use it for real applications. So today I'd like to talk about two of our research. One is video question and answering, and the other is multiple object detections. So this talk involves two topics. Okay, the first one is this one. So text-guided object detector for multimodal video question answering. So this work was done by my student, Roe Shan, and presented in Winter Conference of Application of Computer Vision. So the background is that you know that the video is an important part of our life, And it is important to develop some techniques to automatically analyze the video data. And one of the important tasks in video is video question answering. So which means that given the video and given the questions, and then output the answer to the questions. So, and the application will be, for example, in home robots or video view assistance and automatic video retrieval annotations. So this is a very general view of what kind of system we use for such kind of visual QA system, video QA system. So the component has 3 components. One is object detector, which extracts object features from video frames. And next is a text embedder, which will extract text features from the question answer. And the last module is a multimodal fusion module, which fuses feature from these 2 modalities to make predictions. So this is a general view of the video QA model. And we are focusing on, in this talk, this object detector. So, until this work, most work use off-the-shelf object detector like YOLO or something like that. So object detector has no information about QAs, so it has to extract all the potentially useful information. For example, if you see these images, and the question is, what was Priya holding when she was talking children or something like that. So just would like to know what kind of things they are holding. And these are the focus. But actually, if you apply object detector to this image, it may have outputs many, useless objects which are not related to QAs. And only, for example, man, woman are important, but the other things are all useless. So we have many irrelevant detections, and we neglect many of, for example, it cannot detect this one, this paper documents, important objects. So this is kind of mismatch in the existing object detector and its use to the video QA. So what we developed is a text-guided object detector. So we would like to make object detector which adapts to the video QA model. So this is just object detector, but it actually consists of 3 different modules. And one is a visual encoder, which is the same as before, but we also have text encoder, which we will input text QA information and make texture features, and use not only visual features, but also textual features to get the prediction of the object and its positions. So this is the outline of what we have done. Okay, so I would like to explain one by one. So this visual encoder is just the same as the other models, and not so different. So it uses CNN backbone, extract multiple scale feature maps, and we use transformer encoder to make a visual representation. This is the same as many other works. So for QA, we use BERT embedder, it's a LLM, and get word embedding for each word input. And the point is, we also use post tagging module. Here, post tagging means post stands for part of speech. So we extract only proper nouns and nouns. So to make this kind of, to filter out useless words in the QA. So it is like this. So this is a QA text, and we apply bird, and we just extract, use only the embeddings for these pronoun and nouns. And this is how to call rather complicated, but the last stage object detect decoder. So the point is we use transformer decoder, and we input not only video but also text as an input. Okay, and they output the prediction, output the predicted object label and the bounding box. So we use both visual information and text information to predict the object and the bounding box its positions. So this is our method. So, okay. And yeah, I'm sorry, I just explained these kind of things. It has two branches, and yeah, QA text features influence object content through the cross attention. So we use cross attention inside, and so that output is different according to the different textual input. Okay, so then this is experimental results. Actually, it is difficult to see, but we evaluate our method on TVQA plus data set, and which is very popular data set for evaluating this kind of task. And this is okay. This is a validation test set result. So I would like you to see this second table. So we apply our T-code detector to the framework of the stage, which is one of the famous methods. And we use stage VQA model, and as an object detector, we use T-code. And by evaluate, after the evaluation result is that our method is significantly better than the other method. And also, since we just ignore many objects appear in the image, so it is computationally very light. So which means T-got baseline, which means stage, has a computational amount inference around this value, but our method decreases it into this 2.3. So it is very effective, and also effective in performance, but not only in performance, but also the computational costs. This is T-got, and I would like to skip this slide. So this is a summary of this topic. So T-got plus stage outperforms the original stage by 2% in QA accuracy, and is competitive with previous works. Actually, at this stage, it is a state of the art. And for future, we would like to use more deeper information behind detected object, and the dataset size is still small, so you'd like to increase it. So this is one topic. Okay, and then I'd like to go to the next. So next topic is about multi-object tracking, and it is our student Felix Imanta made a good method called CAMOT, Camera Angular Aware Multi-Object Tracking. Probably I will skip some of the slides first and show you what is multiple object detection. So in this kind of scene, there are many people, okay? And we would like to track every person in this scene. So probably there are many objects which you can think, but in this talk, we are focusing on human beings as an object in this kind of crowd. So, okay. So, in this kind of study, multi-object tracking, the problem is that, as you can see, many occlusions occur. I mean, some person hide some other persons. So we cannot track the person who are behind some other persons. And it is also difficult to have depth-wise distance. I mean, it is a 2D image, so it is easy to measure the horizontal distance, but it is difficult to measure the vertical, I mean, depth distance. So this is a problem in this kind of tracking. So actually, many researches have been done to address these problems. And for example, one study is use a plug-in depth estimator. But this depth estimator is based on the deep learning, and which may take a lot of cost, so computational cost. And another problem is, so what we can do is to lift the tracking into 3D. So we would like to make estimate. We would like to make suit 3D space from the 2D image and do the tracking there. So, but the problem here is that 3D detection tracking is that most of the previous study use non-monocular depth set to generate a depth map and augment sort, and transform a scene into a bird eye view, and then add trajectory prediction. And these methods are actually, again, computationally very expensive. So we would like to have more simple method, which is computationally efficient and also improve the performance. Okay. So, and another, if we would like to make 3D scene from 2D images, we would like to know camera pose estimation, where the camera is. Okay. The traditional method, Lanzak PNP, requires handcrafted features, and these are not so general. And the deep learning-based method can work only with a single image. And most methods requires a dynamic moving video or well-defined structure. So it cannot be used in this kind of multi-object tracking. So this is what we propose. We call it CAMOT, a single, very simple camera angle estimator. So the point is, we assume two things. One is we have the height of the human are mostly the same. And the second is we assume most of the all the persons are just in the same flat plane. Okay. Then, if we assume such kind of things, if we have object detection result like this, then we can roughly estimate the depth of each person, for example, from the scale of the bounding box, okay? And also, we can use multiple bounding box. We know each person's scale, then we can get the camera angle from such information. It's a very simple, geometry problems, okay? So this is what we have done. And I would like to explain, this is a basic idea. I would like to explain them in more detail. So this is a schematic view of the problem, okay? And these blue and red are person actually. And actually they are looking like this, okay? And this is a camera. So we have camera angle theta here, okay? So we would like to estimate this one, okay? And the key idea is that knowing object height h and unknown camera angle theta, and we can calculate everything else. So iteratively estimate the camera angle by estimate the 3D object points using theta, and regress the common plane from the 3D points. Common planes, these ones, okay? And calculate estimation error using the plane, okay? And we just iteratively estimate angle and plane. Okay, so in this way, we can estimate the camera angle. Okay, so this is how we do in detail. So we assume there are many persons in a public space, and assumption is like this: unknown camera parameters. Camera parameters are unknown except for the focal length f. And the focal lengths are almost the same for any of the cameras, so it doesn't make serious problems. And at least 3 objects are detected, and objects are in contact with the ground. I mean, they are just standing and they do not do any jumping or something like that. And also, camera angle may not change abruptly. I mean, it is almost fixed or sometimes moving very slowly, okay? And the problem is find the optimal theta, minimizing error for the best fit plane between all objects. So we use pinhole camera model and objects as cylinders with known uniform height. So this is a very simple assumptions, but it works well. So, and we estimate depth using the detection result, and use the theta to find the distance from the original object, top, bottom points here and here, and convert 2D coordinates to 3D rays, and use a triangle formed by rays like this, and the object to calculate the distances from O to this person, okay? And afterwards, calculate the coordinate for PI, and fit PI to a plane with a normal N and a point P plane. Maybe this explanation may not be well. I mean, I would like to have to take more time, but I'm sorry. So we have 3 kinds of errors in this kind of iteration, which should be minimized. One is the perpendicularity, how much straight ahead humans are standing, and angle error, and also the regression error, which is plane estimation errors. Okay, and we just iterate the estimation process until the error will be minimized, converged. Okay, so this is a kind of details. So bounding box selection, since there are many persons and we do not have to use all of them, so we use very bounding box, I mean objects which are detected with high confidence. And we have to have objects in many places. They should be distributed. So we just select those with a balance in space. And this is an iterative process, so we have to set the initial value first. And since it's a video, so we will use a smoothing technique so that the angle is stable. Okay. And maybe I'll skip this slide. So this is a result. So actually, this is maybe I do not explain detail about the evaluation measure, but these are the maybe first two is the most important one, and these are the previous method, and this CAMOT is our method, and this is about MOT 17 test data set, and then this is MOT 20 test data set, and they are just a data set which is used for some challenges for this motion of multiple object tracking. And as you can see, our method achieved the best result in each of the test set. So this proves that our method is very effective. And also, it is high speed. So these are the previous method, but our method is actually faster than the other method. And we have done ablation studies. I'm sorry, I would like to skip this, but it has, we confirmed that our method is pretty effective. And yeah, this is the, how do you call, how fast is our depth estimator is. And there are many other depth estimator. This FPS higher is better, frame per second. So the other methods are based on some kind of deep learning based method, but our method actually is more than 3 times faster than the other method. So this very simple depth estimator works very well. And also, our angle estimator or depth estimator can be used for many other frameworks. So we apply this work to many other baselines, but actually it's just a plug-in module, so it can bring the improvement in many other methods. Okay. So to conclude this talk, so in this topic, we introduced CAMOT, which is an angle estimator for MOT, and employs heuristics to adapt the tracking behavior to camera elevation angles and achieve the state-of-the-art and computationally efficient, and it can be easily used for many other methods. So future work, we would like to use multiple frames to improve stability and apply to general depth estimation problems, not only multiple object tracking, but for example, any auto driving or something like that. Okay, so this is the end of the second topic, and thank you very much.
Sensei. So if you have questions, please raise your hand and we'll bring the microphone to you. Or for those of you on Zoom, please use the Q&A function. Well, to start, I have a comment actually. I think it's regarding the camera application. It is kind of funny that you require very high computational power just to basically clean the data first before you can actually apply it to the AI. So I think that's a very applicable, very important discovery.
Actually, this problem is very simple. So we do not have to use any deep learning, but it is actually effective. So
yes.
Very unique and quite good.
Right, just using geometry basically, right? That's excellent. Yeah.
Of course, if the ground has a slope and have some angle, it doesn't work well. And if we have human beings with different height, like children or basketball player or something like that. But maybe as you imagine, in usual scenes, all the people may have the similar height, so it works well.
Any questions? Okay, if not, then feel free to contact Shinoda Sensei afterwards at the networking part of the day. Okay, Shinoda Sensei, thank you very much. So that concludes the presentation portion of our event. But don't go home yet because we have the coffee break afterwards. So first of all, thank you all for joining us. Once again, there's a questionnaire in your packet. We would greatly appreciate providing your feedback, as well as for those of you online too, please share your feedback. And the purpose of this event is to form collaborations. So if you wish to collaborate, please contact us. We want to hear from you. And our contact information is on this slide. As I mentioned, we'll have coffee and sweets at the foyer just in the back. So please join us and talk to our speakers. And so Tokyo Tech Research Showcase is an annual event, and we definitely plan to hold this event again in 2025. So we look forward to seeing you again. Okay. So thank you very much all thank you very much all of you for coming, and we look forward to seeing you again. Thank you.